Today we're doing the second part of lesson 3.2. So we will be talking about if our functions, not the degrees, but if our function is even, odd, or neither. So we're going to go through those rules. And then on the end slide, I want to just quick review some of the parent function graphs, because remember, next Thursday you have your first graphing quiz. So I want to make sure that any of those 10 you can do. So I'll do a few today, a few tomorrow, et cetera, et cetera. You need to be able to throw those back to me, just the parents. There aren't even any shifts in them yet, and the domain and the range. And then the next one, I could ask you about end behavior with them. And then the next one, I'm going to have them start shifting all over the place. So please, please practice, but we'll look at those in a bit. Upcoming, tomorrow, survey 3 is due. So please make sure you do that tomorrow by your class period. Survey 3 is due, not at midnight or anything like that. On Friday, you have your weekly homework question on section 1 and 2. I expect it to be pretty quick and easy if you've been doing your homework. On next Wednesday, you have your test on chapter 3. On next Thursday, you have a graphing quiz. Then we're done with all the major assessments for the quarter. Today after school is extra help. Today after school is a retake opportunity. And then on 10/10 is your very last retake opportunity of the quarter. So that's all your upcoming dates. I will be posting, when I get downtime, survey number 4. But I have to play with it because I already tried doing it once and then it overtook survey number 3. So I will be posting survey number 4 later on, and survey number 4 is going to be due on Tuesday. Now, in survey 3, anybody remember some of the questions that I put specifically about equations?
What was the vertex form?
Yeah, vertex form, factored form, standard form. Yeah, I'm really reading those when you do your responses, so make sure you're giving me real solutions, not just gibberish. Secondly, if you needed to put something to a power and you're just typing to me, a caret key, which is an upside down V, you could use that, then followed by the exponent, and then I know you know. Even if you just put it right next to it, I know, or I'm hoping that you knew what to do, that it's not multiplied by, but I'm just telling you in the future so that you know that, okay? The next one is, the next survey is also quick and easy, but I'm looking to see what you know, what you don't know. So please, please really answer the questions, not just sort of. They should all be solutions that you just look at and you go, yeah, I know this. I better know this. Okay, so today's lesson, go ahead. I never pick up tests. Yeah, once I grade them, they're yours forever. Twofold. A, if you wanted to use it to help you study for a retake opportunity. B, I would keep them all to help you study for the final exam, that kind of thing. The retake will have similar, it doesn't have to have the exact same ones. I go back to the study guide and I build my retakes. So a lot of the questions are the same. With different values, but some of them will be different because there were a lot more questions on the study guide. Okay, so now to this. Today we are going to look at graphically and algebraically if a function is even, odd, or neither. Please don't talk. So up here, I have the graph of x squared in black. I have the graph of x to the 4 in blue and x to the 6 in orange. So you can't see if you're not looking this way. Okay, so now looking at these, I need to note some characteristics about it. Could you give me 3 points that all 3 graphs have in common? 0, 0, 1, 1, negative 1, 1. So x to an even power, an even degree, is going to always give me those solid points. I know that for sure. Everything else is going to change, but those are the ones that will stay the same. Now, observation on the 3 graphs. They all look like a concave up parabola. But as my exponent was increasing, look at the x-axis. Do you see how big I made this x-axis? I showed you from -1 to 1. I really blew up the graph. So between -1 and 1, do you see that the bigger the power, the more time your graph is spending right close to the x-axis? So if I gave you x to the 100 power, it would still have points at 0, 0, 1, 1, and -1, 1. Would the graph spend more time close to the x-axis between -1 and 1 than the black graph, or would it spend less time? More. So the bigger the exponent, the more time it gets spread out like that, like almost looks like a horizontal line there between -1 and 1. So now I want to show you how come, what's happening. If I were to graph x to the 12, think about some values I know. I know that 0, 0, and 1, 1 are going to be on there. So I wanted to choose some fraction values between 0 and 1. So into my calculator, I typed 0.5. 0.5 to the 12th power, everybody has a calculator that should be able to do that. Even my phone can do that. 0.000244. Isn't that a tiny, tiny, tiny number? Next, when I plugged in 3/4, I got 0.03167. That's like 3/100ths. That's still a tiny number. So it's really, really, really close to the x-axis as far as its height. When I plugged in 0.9, which I know is close to 1, I got 0.2824. So that's close to about 1/4. When I plugged in 0.99, which is really close to 1, I got 0.88638. So that's way closer to going up to 1. But can you see that with that 0.5, the 0.75, how it's still lying really low, close to the axis? That's how come it's happening. But when I go to plug in a number like 2, the next whole number after 1, isn't 2 to the 12th power going to give you a huge value? That's what's going to make it look like, let's go back to this, that it's going to like zip up almost vertically after the 1, 1 value. Because now 2 comma a huge number is only going that little bit of space horizontally, but an enormous amount of space vertically, like a steep, steep slope. Okay? Now, I want to talk about an odd degree. So here I have a power of 3, and I wanted to compare it to x to the 5 and x to the 7, just like I did your others. So again, I color-coded for you. The black is x cubed, the green is x to the 5, the purple is x to the 7. Observation, 3 points that they have in common. Do I have a volunteer? 3 points they have in common. What do you see?
-1, -1, 1.
Somebody open the door, please. I'm attached. Thank you. Thank you. Yeah. Yeah, I'll take it. I just can't walk far with this wire. I'll kill myself. Okay, so we had 0, 0, -1, 1, and 1, 1. Everybody agree with that? Because -1 cubed is -1. 1 cubed is 1. 0 to any power is 0. We all know that. But if I were to plug in some fractions, so I did it again for you with x to the 13, just so you can see the process. So we know 0 to the 13 is 0. We know 1 to the 13 is 1. When I plugged in 0.5, look at this tiny number, 0.0001222. That is really, 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 really close to the x-axis. When I plugged in 3/4, it doesn't even give me 1/4. It doesn't even give me 0.023. That's 0.02, 2/100ths. That's how close it is. 0.9, 0.254, that's close to 1/4. 0.99, really close to 1, is still at 0.877. So in between that 0 and 1, it's lying low close to the x-axis. That's what I wanted you to see. But if I plugged in a number like 2, 2 to the 13th power is going to be a big number, do you think? Yes, more than your head probably does, just multiplying. So that's going to make it go up really, really, really quick, just like the even one, except for you know your basic shape. So when it's x to the 3, 5, 7, 9, 11, 13, 15, et cetera, 99, you've got the end behavior with, like, my right arm up, my left arm down. When it was a parabola shape, you have end behavior of both arms up, okay? Now, in your textbook, page 235, this is spiral, which means it is like good old-fashioned notes to you, them doing an example. What they're doing right here is they're taking the basic function of x cubed and they're trying to find out, we're going to test the function for being even, odd, or neither. So I need somebody to read this aloud for me. Do I have a brave volunteer that'll read so I can keep my voice all day? Anybody? The graph. The graph of an odd degree.
Graph of an odd degree, basic power function, is symmetric without a point. In particular, the origin.
Wait. Stop. They're being rude. They're going to be the next ones to read. Keep going. They apologize.
A function is symmetric about a point. A function is symmetric about a point. If each point on the graph has a point same distance from the central point, but in the opposite direction. Special attention is given in central point, its origin, as it determines that the function is odd. When the point of symmetry is the origin, the graph is reflected across the x-axis and the y-axis. If you replace both xy with negative x, negative y, the function remains the same.
Okay, so translation, my words. So we're taking a graph like this, and they're showing you in the textbook what's going to happen. So now we're not just testing to see if the degree, the biggest power there, is odd. What we're testing to see is if the function is even, odd, or neither. So it has one more rule than just naming a degree. So since this right here, forget the equation up on top. Since this has one arm up, one arm down, it's either going to be odd or neither. To be odd, gentlemen, it's saying that I'm going to take right here what's in quadrant 1, and I'm going to reflect it over the y-axis, which is picture number 2. Then you see the blue arrow here saying now reflect it over the x-axis as well, which gives you picture number 3. Does picture number 1 and 3 look alike? That's called being symmetric about the origin. If I can take my given graph and reflect it over both the y and x axis, and it still looks the same, then it will be a function that is odd. If it's not symmetric about the origin, then you would list neither. And I have examples of all types in a few minutes. Okay? So that's what this is giving you. So then I put it more in definition terminology. It says an even function has a graph symmetric about the y-axis. So to be even, I should be able to take that parabola and fold the right side over the y-axis, and it's going to land on my left arm. And that would tell me it's symmetric about the y-axis. That's like my axis of symmetry. To be an odd function, it has to be symmetric about the origin. That's what I have to know, and then we're going to practice. So on today's 7 through 12, where you already told me end behavior, now with the pictures we're going to go back and talk even, odd, neither. But I chose different examples so that you can do a few by yourself. Anybody writing down the highlighted info? Unless you just know it. It's up to you. Yes, ma'am. No, not at all. First of all, you're going to establish by the look, when I get to my examples in a sec, you're going to establish if it's going to be even, neither, or odd, neither, depending on the look. Because even ones are going to go through can go through the origin as well. So that's why I said no. That's why I shot that down right away. Because I could have a parabola with a vertex of 0, 0. That would be even. Okay, so let me show you the example. So I'll show you, but on your homework, you actually have two that look like they could either be odd or neither. They both go through the origin. So once you establish that, then it's still going to be odd or neither. It still has to be symmetric about the y and x axis. So it's like all those steps. Okay, so looking at the examples. So look at A. A is either even or neither. Do you agree with me so far? Because of the end behavior. Shake your head. Okay. Now, is it symmetric about the y-axis? Yes or no? Yes. Therefore, it's even. I could take this arm right here, fold it over the y-axis, and it would land right on this arm. Okay. Now, question on that part. We're good? Okay. Look at C. So I'm skipping over to C. It's either odd or neither with me so far because of the end behavior. It is symmetric. I have to look. Does it go through the origin? Yes. So that means it could be symmetric about the origin, but like when you look at your homework later, you're going to see, like what I was saying before, there's one that goes through the origin, but it's still not symmetric about the origin when you look at its shape. This one, if I take this right half and I fold it over the y and then over the x, does it look like this right side would land right on that left side? Yes. So that's what would make it odd. Okay? Now, look at B. It's either odd or neither. With me there, because of the end behavior. Now, does it even go through the origin? No. So as soon as it doesn't go through the origin, it's automatically neither. Okay? So just it has to be careful with the wording, because just because it goes through the origin doesn't mean it's odd. But as soon as it does not go through the origin, it has to be neither. Is that better? Okay. Question. Okay. So does anybody need a picture of this as an example, or are you good? Okay. So I would put a question that I think is really easy, just like this, on your test. It should take you as long as it takes to read the problem to answer the question. Good save. So look at number 9 real quick in your homework, if you have it out. Look at number 9 versus look at number 10 in your homework. One of them is odd, one of them is neither. See how they're both, and behavior looks like it could be odd. They both go through the origin, but both are not symmetric about the origin. Which one is neither? Go ahead, Jay. Number 9 ends up being neither. Do you see why? Okay, that's what I need you to visualize. Okay? Question. Okay, since this question came up last hour, I typed it in. Odd and even functions, what we're doing right now, is not the same thing as saying odd and even degrees. A degree is like the biggest exponent there. So I look at that, but that isn't the whole thing. To decide if it's an even or odd function, once I establish that, oh, it might be an x squared, so it's either going to be even or neither, okay? But an odd or even degree is just saying the biggest power there is even, or the biggest power there is odd. But it doesn't denote everything about the function itself, the entire graph, okay? That's what you're talking about with the whole function. Okay, so next thought. Now I'm doing this algebraically, like the next set of problems. I put one of these on the test as well. So the rule for testing algebraically is actually really easy. You are going to replace all the x's with negative x's. And you're going to take it to its respective powers. So far, that's what Lillian and Destiny did to start. Then we'll talk about what I have to notice. But look at their work. So Lillian replaced all of the x's with negative x's. Do you see so far what I'm doing? And then she said negative x to the 4th power is a positive 3x to the 4. And then she did all the other parts. Do you see what she did? Over there, Destiny, by accident, I hope, put the exponents inside the parentheses. which means why bother with the parentheses in? So with hers, she has the negative inside, then the x, so she's not going to be taking the negative to the power. So when she does that, she ends up with a negative 3x to the 4, because x to the 4 stayed x to the 4 the way she did it, and then negative times 3 is negative 3x to the 4. She's wrong. That's why there's a thumbs down. Let me finish, and I'll take your question. So be really careful. Do you see how Lillian has the exponent outside? Destiny messed up across the board. She has it inside. You want it outside because then you're taking both the sign and the variable to the exponent. Okay, so that's step one. Question?
I don't understand why we plug
I'm going to get there. Right now, I just wanted you to see the difference of the math, doing it correctly. So to test if something is even, odd, or neither, you're going to plug in negative x wherever there's an x. To be even, every sign has to stay the same after you do that action. To be odd, every sign has to be the opposite of what it was after you do the action. So here we go. Even, you see the word even there, and then in parentheses, and I highlighted in that pretty color there, if it is the same as the original. So you've replaced all your x's with negative x. You've taken everything to its respective powers. Now you're comparing. If every sign is exactly the way it was, even. Next, you've done your math, you've plugged in the negative x, you've taken it to its respective power. Every sign is the opposite of what it was originally, then it's odd. As soon as there's a variation, then it's neither. Okay? So as soon as neither of these fit, then you write neither, because neither fit. And we're going to practice that as well, and hopefully you'll find it as easy as everybody else has so far today. So the rules, make sure you have them, because I put one of these on the test. I put one on the test. Anybody still writing? Okay. We good? Everybody done? Yay. Okay, so same rules I had on the other frame. We're going to do a couple of these. So look at A. So I look at the sentence, and right away I can rule out one of the three. The biggest exponent there is 3. So it's either going to be odd or neither. Those are my two choices. Are you with me so far? Correct. So since the degree of the problem is odd, the biggest power there is 3, then it's going to be odd or neither. Now, next thought. Wherever there's an x, let's replace it with a negative x. With me so far there? Let's do the math. Negative cubed is a negative. Negative times a positive is a negative. I truly don't care what the numbers and variables are. I just care about the sign. Next, what is a negative times a negative? Positive. Okay, let's look. This one was a positive. Now we've got a negative. This one was a negative. Now we have a positive. Did the signs all change? Are they all opposite? So is it odd or neither? Odd. You've got it. Very good. Question? Yes? The rule is to check algebraically. You're going to replace every x with a negative x. Yes, always, always. That's the first step. But you're putting it inside the parentheses, so you would have a negative outside and then a negative x inside. Okay, so look at the next one. Some of you, if you visualize, if you can picture this, if you understand graphs, some of you could picture what this graph looks like and know the answer just by thinking it in your head without doing the algebra. Some of you will need to do the algebra. So I'm going to think out loud what I see. When I see 6x squared, I see a parabola opening upward. Do you? Okay. Now, a plus 10 hanging at the end is telling me to move my graph up 10 units. So you don't have to draw a picture, but you can't read my mind. So that is what I see. All I'm doing is scooting it up the y-axis. Would that be symmetric about the y-axis? Could I fold it on the y-axis if I made it prettier? And it would land on its other half. Yes. So I can look at this and I know already that it's even without even doing the algebra. Now, here's the algebra. Wherever there's an x, replace it with a negative x. Do you notice that constants, the signs won't change? There's no x. How can a sign change? So you know a negative squared is a positive times a positive is a positive, and I'm going to bring the sign down. Did my sign stay the same? Yes. This was positive, it stayed positive. This was positive, it stayed positive. So my choice here was even, because of the 2, or neither. And we would say even. Question. Okay, let's do a third one. Wherever there's an x, you're going to replace it with negative x. And some of you, as you get really good at this, you're going to be able to look at the sentence like this, and you're going to know the answer without any work because of something that has to happen. Hopefully you'll have that aha moment. Okay, so what is a negative cubed? Negative. Anybody already know the answer? The choice is going to be odd or neither. Okay, I heard odd over here. I heard neither over here. Do you know why it's neither? And then I'll finish the problem. Okay, so he noticed something in the pattern here. There's something even quicker before I even wrote anything in that I would have noticed. Well, we want every x to change, but there's something that never changes. The 7, didn't I say the constant can never, ever change, right? There's no x there. So if every sign has to change, but 7 can't change, can it be odd? No. So that's how I could look at that. So as long as there's a constant, I can make the decision that quick because there is no way that one's going to have the opposite sign. But if you didn't believe me, or you didn't trust me, or you were iffy with, oh, what if it's that one exception to the rule? There's not an exception to the rule. But if you were second guessing yourself, here's the math. Negative squared is a positive. Positive times a negative is a negative. So already you can see that that sign's not going to change. Maybe you're still going, oh, no, maybe I still messed up. So negative, negative is a positive. Oh, well, that sign changed. That one did. And then here, this one's going to be a plus. That sign didn't change, so it has to be a neither. But I love it when you can catch it, understanding the math of what's going to happen or not happen to know if it's even, odd, or neither. Okay? So there's one like that on your test as well. Question? Okay, so that's it. I took a last year one-day lesson and broke it into two, so it would be really easy for you. What I would like to do right quick is, here, let me give you the assignment. And then, maybe, oh, it's thinking. And then I want to do a couple graphs with you. So your homework is finishing up on 3.2. 7 to 12, you're telling me even, odd, neither. You already have the end behavior there. And then on the 14 to 18, you're working it through algebraically, in other words, plugging in the negative x to tell me even, odd, or neither. You are starting to work on the study guide, so you're not doing it all at once. You know that you have a weekly homework question on Friday with what we did on 3.1 and 3.2. So if you've been just listening even, you should be really good at that. Survey 3 is due tomorrow this time, and Survey 4 is due on 10/2, okay? And it will be available for you soon, as soon as I have my own quiet time. Okay, now, how am I doing on time? 10:33, I still have 11 minutes. Tell me when you're done taking pictures so I can move. Anybody else before I move? Do you guys look at these pictures after you take them? Okay, so as you're doing this, and as I go back and I'm going to do a couple graphs with you to get you ready for next Thursday's graphing quiz, remember on Focus, besides the surveys being posted there, besides these podcasts all being posted there, besides my study guide and my study guide with all my work being posted there, the skills practice is there, blank, like if you lose it or you get home and you're like, oh yeah, she didn't give me a single handout, I forgot to bring it home. It's in my gym locker after football practice or something like that. You can print it from home. The whole PDF is there for every chapter, chapter by chapter. Then, underneath that one, I put a PDF with the skills practice with solutions so that you can check your work, so that if you come in and you're totally confused on something, you know what you don't know and you know what to ask me. If not, I'm thinking you know what you're doing, okay? So please use that to check yourself to be good. Your solutions are already there for the study guide for Chapter 3, so you can be great at that. Okay, now with that being said, I would like to talk a little bit about the graphs that you are responsible for come next week. Any of the 10 on your parent function sheet that you got way back like the second week of school that we filled in together over like 3 different days, and then one of the days I was out, that was part of your homework when I was out in September, well, early September, that was you practicing it again. So I took 5 of these, as well as asking you about domain and range, and I expect it to be a quick, graph it, give me domain and range. So to refresh your memory, what if I give you y equals absolute value of x? Do you know what shape absolute value makes? V. So when I go to sketch this, this is how quick I would expect you to sketch it. And these are individual. They're not any group quizzes or anything. The only thing we do together is your weekly homework questions. I see this, 0, 0, 1, 1, negative 1, 1. Does everybody agree? So it actually starts similar to a parabola. It's just that if you plug in a 2, it would be 2, 2, negative 2, 2. Guys in the back, listen. You're going to be the ones that miss this. Now, what is the domain? What can I plug in for x? Anything. So my domain, if you remember, we wrote was negative infinity to infinity. That's how we wrote our all real numbers. The range is not anything. Okay, no, okay, so all positives in 0, which means I want to include 0 all the way to the infinity. So that's saying all positive real numbers from 0 to infinity. Okay, make sure you can throw that back to me.
So you only have the bracket on the left side?
Only on the left side on that one because 0 is included. So you use the bracket if you're including that spot. You use parentheses if you're not including it. You use parentheses always around the infinities because they go on forever.
So every time you hit 0, there's going to be one bracket.
Well, if this had been, if it was a generic graph and I made that an open point instead, then I would have had a parentheses. But if it's a filled in point, I make a bracket because that means include me. Is that better? Okay. Let's look at another. If I gave you this is what they wanted to practice in second period. Piecewise function. I can make up any 2 or 3 pieces I want. That's what I do when I'm doing the lessons up here and I give you those funky looking graphs that we've been talking about. I go to Desmos and I type in a few equations and I give it some stipulations and it makes these lovely graphs for me. So the first graph on this handout had said y is equal to x, but I want it to happen when x is less than 2. So I gave you 3 different pieces. That's what a piecewise function is, 2 or more pieces. So the first one is a nice diagonal line, y equals x. But I only want values where x is 2 or less, okay? But since there's no equal sign there, it's going to be an open point at 2. So the line y equals x have points at 0, 0, 1, 1, negative 1, negative 1, 2, 2, but I put an open point there. How come again? Good, no equal to. So here is the first part of my graph. Question on that? Okay. Graph number 2 said graph y is 2. That's a horizontal line with a height of 2. But do it between negative 2 and 6 and include them, which means fill in the points. So between height of 2, x is 2, height of 2, x is 6, draw a horizontal line. So there's my pretty segment. Still with me? Yes?
What about I thought that was negative 2.
Oh, I messed up there. Between positive 2 and 2 and 6. Yeah, that's my fault. It's because I didn't look at the paper. And then the last one says graph y equals 2x minus 10. And I want to do that when x is bigger than 6. So if you plug in 6 into this linear equation, 2 times 6 is 12. 12 minus 10 is 2. Do you already have a point at 6, 2? Yeah, we do from the last one. Okay, so that's there. So let's plug in another number. How about 7? 7 times 2 is 14. 14 take away 10 is 4. Very good. So we have a point at 7, 4. How many points does it take to make a line? 2. So a third, we make sure you're correct, but it really only takes 2 points to make a line, and there would be the other part. If you didn't believe me, you could plug in 8. 8 times 2 is 16. 16 minus 10 would be 6, so you could see the nice angle it's on. That's a nice piecewise function. Every piecewise function is going to look different because they have different equations. Specifically this one, where it's connected, so it's continuous. Do you know what the domain was? Is it going to the right forever? Is it gone to the left forever? It's all real numbers. What about the range? Is it gone up forever? Is it gone down forever? Yes. What's your range? All real numbers. Okay? So tomorrow, the next day, etc., we'll keep practicing these so that you can be amazing at them and get them right as well. Okay?